Thank you. Hello, everyone. It's a pleasure to be here. So my name is Berenice Le Glouanec, and today I'm going to present you our newly published guideline for the assessment of the reliability and trustworthiness of machine learning systems on maritime context. So this is also known as NI692. So as a bit of an introduction, Bureau Veritas Marine Offshore is a classification society that is usually involved in the assessment of safety and compliance of maritime aspects on board shores, on offshore structures. They are involved from design to operation and maintenance of those maritime assets. Nowadays, we have many AI components on board marine aspects, including, for example, condition and monitoring and predictive maintenance with anomaly detection or structural hull monitoring. We also have lots of use cases regarding navigation support with anti-collision systems and situational awareness. And finally, we face many use cases regarding energy efficiency with route optimization as well as consumption optimization. Today, my talk will be divided into three main parts. First, I would like to introduce you to the regulatory context in which we are driving right now in the maritime world regarding AI. Then I will provide you with the usual lifecycle approach we are taking regarding machine learning systems. And finally, we will dive into the assessment and content of the NI692 regarding machine learning systems. So first, as per the regulatory context, know that this is also part of the Appendix 1 of the NI692 that you will be able to have a look on later on. So first, as per the international landscape, so we have a few organizations, such as G20, OECD, or UNESCO, that have agreed on common AI principles to be considered when developing AI systems, such as transparency, traceability, robustness, accuracy, security, and so on. Then we already have several ISO standards. Here, just a very small example and non-exhaustive list that have already been developed. So as per the maritime regulation, so far at IMO level, the biggest intersection, we do not have anything related to the regulation of AI systems. As per the International Association of 12 classification societies in which Bureau Veritas is part of, we have a first recommendation for ship data quality that has been published in December 2024, so it is quite recent. And we have a non-monetary maritime autonomous surface ship code that will be scheduled for adoption in May 2026, meaning so far we do not have any regulation on AI. As per the European landscape, you are probably all aware of the AI Act. So this is a risk-based approach to regulate AI systems, and it classifies them into 4 different categories. Most of marine use cases will fall under high-risk systems, requiring specific rules to comply with, such as strict risk management, transparency of the system, data governance, and human oversight measures. Alongside, we have a standardization request that has been issued by the European Commission. At the moment, we have several harmonized standards, that are still in progress, such as risk management, trustworthiness framework, bias management, quality and governance of data sets, and so on. So the key point here is that the AI Act actually recognizes any maritime asset equipped with AI as a high-risk profile. However, unless the European Directive on Marine Equipment is updated to include the AI Act, this does not apply to any AI solutions on board vessels, for example. So at the moment, we do not have any regulation on AI specifically for maritime aspects. This is where we are. So as Bureau Veritas, we decided to try to set up a preliminary framework to specify some guidelines on how to assess the reliability of the machine learning systems on a maritime context. It is fairly aligned with the lifecycle approach of the systems. So this is something that you will be able to find in section 1 of the document. So when we talk about the machine learning system lifecycle, we consider the whole aspects from data governance with data collection, preprocessing, development, model selection, validation, and so on, as well as the operation of the machine learning system, meaning monitoring as well as maintenance. So here we are fairly aligned with the trustworthiness aspects that should be aligned along the whole life cycle of the machine learning system. This is where our document belongs. So it is fairly related and based on the life cycle approach. And it is composed into 5 main parts, including operational descriptions. We'll go further into that later on. Risk management, data governance, development and implementation of the system, and finally, operation and maintenance. This is where I go. So bear in mind that it's not about technical novelty, but about providing governance framework. So this is mainly the section 2 of NI692. So first, the operational description of what matters most to ensure a machine learning system functions safely and effectively. So here it is divided into 3 main parts known as the operational context. So first, we have the concept of operations. So here it provides information on the tasks and functions of the system, intended domain of uses, as well as foreseeable misuses of the system. Limitations, meaning what the machine learning system is supposed and not supposed to do, as well as modes of operation. The operational envelope describes which factors make the system being considered normal or in degraded states. It details plans to mitigate degraded states and also defines expected interactions with infrastructure or dynamic objects. Finally, it also provides information on the environmental, operational, and geographical constraints in which the machine learning system will operate in. Finally, we have the operational design domain. So here the idea is to define environmental as well as operational conditions to be met for operating the system, instructions for normal and emergency operations, as well as foreseeable malfunctions of the system. So the objectives here is to provide an accurate and complete overview and description of the machine learning system to better understand intended uses, expected functionalities, as well as constraints and limitations. Still part of the operational descriptions, we recommend to document the functional analysis. So here it describes functions, whether they rely on the machine learning system, and hardware dependencies. Then human oversight and automation. So the idea here is to ensure that sufficient supervision is implemented according to the intended use and the degree of automation of the system. Finally, we have roles and responsibilities to keep track of tasks and accountabilities of involved stakeholders at any point in the life cycle of the machine learning system, from development to operation of the system. So all these help setting out the dependencies and potential conflicts or failures to help building later on the risk assessment to forecast any potential failure propagations. Moving on to the risk management on how to identify and mitigate risks in machine learning system. So here we recommend regular risk, bias, and impact assessments to consider emerging risk at all times. The key message here is that there will never be a time where all risks are covered and the job is done. So constantly anticipating new risks is what keeps machine learning system resilient and secure over time. Risk assessments are performed by identifying hazards, analyzing causes and consequences, and implementing appropriate mitigation layers. You can also find an example of risk assessment in the Appendix 2 of the NI692. To complement the risk assessment, we provide recommendations for the implementation of minimal mitigation layers, considering procedures for emerging emergencies and alerts requiring immediate human supervision, redundancies and backup systems in case of failure, controllability measures to ensure any operator is able to halt, shut down, or stop the system at any given point in time, controlled access to limit unauthorized users, designing dedicated human-machine interaction interfaces to display sufficient but understandable data so that the operator is not overwhelmed by too much information. Also procedures for collecting the operator's feedback, and a human agency to ensure that we prevent over-reliance on the system. We also provide specific mitigation layers for the reinforcement learning agents, such as reward function safeguards and circuit breakers. Moving on to the operator training, we believe it is very important to take them into consideration to maintain effective human supervision and ensure they have appropriate knowledge of the following: intended uses and foreseeable misuses of the system, as well as the functions and limitations associated. The control procedures, halt, shut down, or stop the system, ensure that they have sufficient knowledge and understandable of output and how to interpret them. Ensure that they have sufficient knowledge to be able to identify any performance degradation, any biases or anomalies going on. Also to provide them with appropriate and inappropriate interactions they are supposed to do with the machine learning system. And finally, to ensure they have generic as well as context-specific risk with their own use cases. Moving on to the data governance, or how to ensure data integrity and accuracy before training a model. So you are all aware that quality of input data will directly affect the quality of the output. Therefore, if the data is insufficiently curated and controlled, it alters the reliability and trustworthiness of the machine learning system. So very aligned with the AI Act, we recommend to ensure traceability and transparency of the collection and preprocessing of data, to enhance data governance among stakeholders, and for example, to perform systemic analysis, bias, or anomalies among datasets. Transparency implies documenting the collection process, including the metadata, data provenance, storage location, and so on, as well as cleaning and preprocessing transformations on data. We recommend to evaluate the quality of data against 9 specific dimensions, such as accessibility, availability, completeness, relevance, and so on. Finally, we recommend to document any processes that may affect the reliability of the data, any transformation. Also, for example, the labeling process, the purpose for use of the data, any data rights, the metrics and solutions in place to perform bias detection, and finally, confidentiality and access restrictions measures. Moving on to the development of how to ensure transparency and reliability before deploying the machine learning system. So we consider that explainability of models helps build trust. The more models are explainable and understandable in their decision-making process, internal data processing and expected outcomes, the more they are trustworthy, as stakeholders are more aware of their capabilities and limits. Therefore, we provide recommendations for the descriptions of the technical environment to deploy and maintain such system, meaning the architecture, the source of algorithm, decision-making process, and for reinforcement learning, exploration, exploitation, balance, agents, environment, actions, and interactions. We also provide recommendations for the evaluation of models as well as validation of the whole machine learning system against specific contextually relevant dimensions such as robustness, interoperability, model complexity, real-world scenarios, interpretability or result, and so on. So this is shown as providing the evaluation metrics taking into account what are the purpose of the machine learning system, a description of what it is supposed to perform and why this one is picked, and also providing the acceptance criteria, thresholds, minimum, maximum that are expected to comply with this evaluation metrics. Moving on to the implementation. So here we provide mitigation layers to ensure the traceability and auditability of the system with logging and record-keeping measures, meaning we have runtime evaluations that are performed against predefined thresholds. For example, contextually relevant metrics, appropriate thresholds, output confidence, as well as input data quality checks. Then we have the operational logs containing operational event state, environment, and operational conditions. We have the significant events, incident descriptions, affected subsystems, mitigation measures, as well as notified operators. And finally, the maintenance reports to keep track of relevance of updates for the intended domain of use. We also recommend to implement specific safeguards for operational safety to halt down the system whenever there are unacceptable score criteria, quality thresholds are not met for input data, input data is unavailable, there is a shutdown of the system, an anomaly is detected, or it is being operated outside its intended purpose or intended domain of use. Moving on to the operation and how to maintain reliability and safety of a machine learning system after deployment. So here we fairly recommend to perform ongoing monitoring of the input data quality, the output performance to detect any degradation over time, the domain of use, and as well as human-machine interactions to prevent any misuse of the system. We specifically recommend active human supervision for continuous learning and reinforcement learning agents. Alongside, to ensure performance and reliability of machine learning system over time, we recommend to update the system based on operators' feedback, the availability of new technologies or new data for retraining, for example, or that while re-evaluating the system and assessing the risks and biases at all stages previously mentioned to keep the system aligned with intended use and expectation. So the key message here is that responsible machine learning doesn't end at deployment, but it grows with vigilance, updates, and specifically human insight. So this concludes my presentation. If you are interested, feel free to scan this QR code and have a look on the document. And if you have any feedback, we'll be very happy to discuss it or to have any update on the document as well. For your information, we are in the process of developing a guidance note for ship data quality that is very related to what I presented today, which is called the NI692, and it is expected to be published in mid-2026. Thank you for your attention. I will be happy to answer any question.
Well, thank you so much, Berenice, for a super interesting and inspiring presentation. We do have questions for a few. We do have some couple of minutes for some questions. The first one is like, how do you manage to accord or like keep up with your guidelines with the current speed of like AI development and AI models?
Yeah, thank you very much for this question. So we are very engaged in Sensenelec deployment. So this is the standardization, European standardization organization, and we are very involved in any meetings they have, and also taking a huge part in their work towards the standardization of AI and standardization of machine learning. And especially we have a lot of small workshops as well with other classification societies to ensure that we keep up on the evolving trends and technologies regarding AI and maritime aspects.
Thank you so much. And I was just really curious about, like, what does actually good human supervision look like on board on a vessel, maybe like an offshore setting? Do they have like data science teams on these vessels, or is this done like more onshore? Do you know that?
My answer would be that it is more done onshore. This is where we really try to be there for the operators that. For the crew on board ships, for example, that see all these emerging technologies and maybe do not have the full knowledge of how to interact with it and what to expect from the machine learning system as well. So this is where we recommend to have a very active human in the loop situation, so that they are part of the discussions to regulate the AI system, and also to ensure that their feedback can be taken into consideration whenever they are working with that.
Right. I understand. Thank you so much. And with that being said, we do also have this beautiful gift to you, an umbrella, and give Berenice a warm applause. Thank you so much for being here. Thank you.